Alright, we're back for a quick short video. In the last video, I showed you guys this limit rule and I showed you the graph. The limit as x approaches 0 for sine theta over theta is always 1. So you can look at the graph if you want to see why that works, but I wanted to show you how you apply that on some different examples. So the first one here is that theta and theta have simply been replaced with 8x and 8x. So because those are the same, the value of that limit is 1. So I just wanted to show you sometimes you can see it like that. Here's one that's a little different. It's the limit as x approaches 0 of sine 2x over 5x. So those values are not the same, so you have to manipulate it a little bit to get it the same. So one thing you can do to start off is to rewrite sine 2x using your double angle identity. So remember this stuff we learned last year, sine 2x is 2 sine x cosine x. So I'm going to replace that. So I'm just going to rewrite sine 2x as the limit as x approaches 0. I'm just using this one right here. 2 sine x cosine x over 5x. Now I can take this, the 2/5 out, because that's just a constant. I can just take this and separate it. It's the same as saying 2/5 times all that. So let's rewrite it as this equals 2/5 times the limit as x approaches 0 of sine x cosine x over x. Remember, that was one of our limit properties, that you can pull the constant out. Now I'm going to separate this into two different limits. So this is the same as saying 2/5 times the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of cosine x. So why did I decide to separate it like that? Because now this thing, this second part, this second limit here in the middle is the identity. So I know that's 1. That's why I decided to pull these out together. Okay, so now I have 2/5. I know the value of that limit is 1. Now what is the limit of cosine x as x approaches 0? So you can use your unit circle there, because you can just direct sub in. What is cosine of 0? Cosine of 0 is 1. So the value of this limit is equal to 2/5 times 1 times 1, which is 2/5. So my answer, which I'm just going to do like this so I have some space, is that the limit as x approaches 0 of sine 2x over 5x equals 2/5. It's a lot of work to just pull those numbers out, but that happened to work out that way. If this value was not 1, it would have been a different number. So don't always assume you can just take the numbers out. All right, what about this one? The limit is theta goes to 0 of tan 3 theta over sine 5 theta. So I see this tan 3 theta, I know I'm going to replace it with this thing, okay? So I'm going to rewrite it. The limit as theta approaches 0 of sine 3 theta over cosine 3 theta, whole thing over sine 5 theta, right? I'm just using my identity there for tan. So now I know I can flip this thing to multiply by the inverse. Times, this just becomes 1 over sine 5 theta. Okay, so I'm there. So now what am I going to do? Well, I'm going to rewrite, kind of like I wrote this into 3 parts, I'm going to rewrite this too. I'm going to combine these, and I'll show you why in a second. So I'm going to rewrite this as the limit as theta goes to 0 of sine 3 theta over sine 5 theta times 1 over cosine 3 theta. Same thing, just rewritten differently. And why am I doing this? Because we had a rule, which I wrote yesterday, where it said if sine ax over bx, the limit of sine ax over bx is just equal to a over b. So I know that this part right here is equal to 3/5, okay? Which I guess I could have done here too, right? Because I just proved it by doing all this, but it's that same rule. So then, because I would do all of this again to get to this same point, if that makes sense. And then now 1 over cosine 3 theta, so if I plug in 0, it's 1 over cosine of 0, which same from up here we know is 1. So it's times 1. So the answer to this limit is 3/5. So I'm just realizing I did this whole long way, but it was a great proof to show you why I could just make this 3/5 here. Okay, so hopefully that helps you be able to solve some of these trig problems using this rule. This is just something you'll have to commit to memory. All right, see you next time.